All right, this is lesson 7-7, simple and compound interest. Now, this is the formula that we use for simple interest. Interest equals the principal, which is the amount of money you put in, times the rate, which would be the percentage rate that you would be getting your interest back, times t, which it would be the time, or the amount of time that it's in the bank. So let's say if they say you deposit $500 in a savings account, the interest rate is 4% per year. I would take this information and plug it in to my formula. So I would do 500 times 4%, which I'm going to write as a decimal to be 0.04, times however many years I'm going to put it in. In this problem, the one that they do, example 1 in your textbook, they say for per year for 6 years. So I multiply by 6. When I multiply that together, I'm going to get a value of $120. This is the interest that you earn. So be careful about reading the directions and if they're asking for the interest earned or your balance. If they're asking for the interest earned, 120 is it. If they ask for the total balance, you're going to have to add in the amount of money that you started with in the bank. So in this case, if I wanted to know my total balance for putting my money in for 6 years, I would add those two together to get 620, which hard to see on the screen. All right, right here, $620. That's pretty simple because it's simple interest. Now, compound interest has a little more going for it, but in the end, compound interest works out better for us because typically you get more money because your money is being multiplied for each of the interest periods, and the money that you earn is also being multiplied. So the formula is your balance is equal to the principal times 1 plus your rate, power of n, with n being the number of interest periods. So this one, it's not just yearly, it can be, but typically you'll have, it'll be compounded semi-annually for a number of years. So you'll have to figure out how many times each year is the interest period occurring. And we'll work on that in just a second. Let's say though, the problem is you deposit $400 into the bank, and it is compounded annually, so once a year, at a 5% interest rate. So 5%, I'm going to change that to 0.05 annually for 4 years. Okay? So what I'm going to do is, at this point, follow my order of operations and solve my inside the parentheses first. I would do 1 plus 0.05 to get 1.05. Raise that to the power of 4, and then multiply that by 400 to equal $486 and 20 cents. So this is the basic idea for compound interest. Now, we also need to take it one step further, and at this point I would reference page 373 in your textbook because it helps explain it. But let's say they give you a different problem, and it's, let me find it here. Okay, you deposit $1,000 that earns 4% interest compounded semi-annually for 5 years. So you are working with a semi-annual compound for 5 years. So that means twice a year for 5 years. So your time, instead of just being the number 5 for 5 years, twice a year for 5 years would be 10. So whenever I'm plugging in my value, $1,000, 1 plus my rate, which we'll get to in a second, the interest is going to be raised to the power of 10 because it's twice a year for 5 years. So how many interest periods I've got is 10. Now, because my 5% interest is over the whole year, but each interest period gets some of that rate. So therefore, if I've got 5%, or excuse me, 4% interest for the year, and I've got twice a year, I'm going to have to divide that by 2. So instead of 0.04, I'm going to do 0.02. And then I'm going to solve that out. I would do 1.02. 1.02 to the power of 10 equals 1.218. So I'm going to do 1.22 times 1,000 to get a value of $1,218.99. Again, I would reference page 373 in the workbook, or ask me if you have questions on this. It's the compound interest formula, but be careful about your rate and your interest periods.